All right, do you guys have this noted down? Last class, we did something called constructive and destructive superposition. So constructive superposition is when your waves are perfectly aligned and you have everything same with what is the amplitude, double the amplitude. And destructive superposition is when the waves are perfectly identical, but they're completely out of phase. And when they add up, what do you have? Like a flat line like that, right? So that's your constructive destructive interference. Right? Oh. TV is on the thing. Yeah, book one.
I think if you had it posted the latest class.
Yeah, I'll do it together today. Okay, this will be back in a minute. Can you go to page 47? Ask you 47 start करबो. Page 47. Right, so we'll be starting a new topic. It's a topic on its own called a stationary wave. I gave some introduction to it last class, but I'll start from scratch again, okay? So what's a stationary wave and how to create a stationary wave? So stationary wave হচ্ছে by definition হচ্ছে a wave that does not transfer energy away, or you can say a wave that has confined energy. So we'll see this. Why is it like that? Okay, do not write anything. I can take a heads up data key. It's a little complicated. So if you don't get it the first time, second time, third time, it doesn't really help that much. Okay, so first time is important. So yeah, what is this stationary wave and how does it form? So imagine you have a rope that is tied to a rod like that. So there's a rod like this, and you have a rope that is tied here. So you can not the tie kora, and it's tied there as well. Can you picture what's happening? So you have a rope that is tied at both ends. They can't move. Okay, and these ends can't move. So what you do is you provide energy to this rope, and the way you provide energy to a rope is by plucking it. So as you bring it down like that, you provided energy, which is what form of energy? As you bring the rope down, very good, elastic potential energy, right? And as you release that, the elastic potential energy gets converted to kinetic energy, then back to elastic potential energy, and it keeps doing that, right? But as it does that, what is generated here is that there will be some waves generated, transverse wave, because you pluck the rope up, and then it went down. That's the movement that generates transverse waves. And this is very, very basic concept. Okay, so what's happening is that there is a wave generated here. Now this wave will travel along the rope, and it travels like that along the rope, right? And it goes there, and and it hits this boundary there. It's called a boundary edge, right? Now the problem is, if you look at this wave here, the one that I have here, the first part of the wave is trying to move which way? Downwards, right? So if you try to bring it down, they'll try to bring the knot down. The knot is fixed, so it can't go down. So because of the reaction, right? Which will the rope experience force upwards. I'll give you an idea. Okay. So imagine you have a rope hanging muscularly, right? You give it go downwards, and it comes downwards, which will experience the force on your hand upwards. You can law, right? So every particle in this wave is trying to bring this rope downwards, right? But it can't, right? So the rope applies force on every particle which way upwards. So what consequence of this? Consequence is, as the wave comes towards the place, right? It hits the boundary, and then it goes back. When it goes back, it goes back completely what the original wave, opposite of the original wave, and the wave becomes completely what? Out of phase. Okay, so if you look at this wave here, this is the wave that goes back. This is the reflection that we're looking at. So it looks like this. Okay. Now at this edge, you know, in and out, at that instant, the waves look like this. The one that's coming in is known as the incident wave. Remember incident light? This is the incident wave, and the gray color one is the what wave? Reflected wave, right? So the idea here is that the incident wave and the reflected wave, right, will interfere at that edge. And when they interfere at that edge, what are they to each other? Completely out of phase, right? And if they're completely out of phase, what will be the resultant? I think you just mentioned it will result in a what? Destructive interference, right? And destructive interference যখন হয়, what is the phase difference or path difference that results in a destructive interference? Phase difference is কত? Pi, right? And this results in something called the destructive interference. Destructive interference means that the amplitude resultant would be how much? 0, right? So at this location of the rope, you will notice that the rope doesn't what? Vibrate. And there's a name given to this kind of a location. It is called the node. So node is an extremely important term in our syllabus. Okay, so what's a node? It's a point on a wave, right, where what interference has taken place? Destructive. A node is like a dot, a fixed point. So you can go to vibration notice for one. Okay, so what we notice is that if you take a rope, right, and I'll show you many animations on this because the animation when you take a rope and you allow it to oscillate, and then the rope goes and hits a boundary and then comes back. When it hits a boundary, if the wave is going like this, right, when it comes back, what does it do? Flip completely, 180 degree. I think I showed an animation last class. Remember with the pulse? The pulse goes like this and then flips over and comes back, right? So this is the first thing that we have to, excuse me, we need to understand that as a wave goes, hits the boundary and comes back, what does it do? Undergo a phase shift of how much? 180 or pi. Are you with me so far? Acha. But the thing that students will usually forget is that আমরা যখন একটা stringকে plug করি, there are hundreds of these waves moving in. Hundreds and hundreds of waves because frequency উপর depend করে. So এরকম waves খালি যাচ্ছে আর যাচ্ছে, okay? Similarly, how many waves will be reflecting back as well? Hundreds of them as well, right? Equal number. So যেটা হয় is that as these waves travel forward, this or these waves also travel which way? Backwards. And what do they start to do with each other on their way back? Interfere. আচ্ছা, so এগুলা যেগুলা reflection back করতেছে আর যে incident গুলো সামনে যাচ্ছে, what do they do on their way back? They interfere. And the thing is, they interfere differently at different places. I'll show you what. So remember at the edge, this is the edge, right? The two waves were what to each other? Completely out of phase. So এই যে একটা এরকম দেখতে ছিল আর একটা হচ্ছে এরকম দেখতে ছিল, right? So that was how it was. আমরা একটা জিনিস করব to make it simple because এই wave pattern টা অনেকে বুঝতে problem হয়. I'll draw two lines here to give you an idea how the waves look like. So if this arrow represents my incident wave, can you tell me, excuse me, how can I draw my reflected wave here to show 180 phase difference? এটা কি same upright থাকবে নাকি পুরো উল্টা থাকবে? Yeah, online one of you said it's going to be completely upside down. Upside down যদি থাকে, just look at this. Aren't these two vibrations completely opposite to each other? We'll use this. This is easy to understand. Okay, waves to oneka buche na. So at this particular location, at the edge, right? What are the two ways to each other? Completely out of phase. So what would the resultant be? 0, right? Acha, fine. একটু আগে যদি আসি আমরা, like a little bit earlier here, তখন যেটা নোটিস করা যায়, they're not completely out of phase. একটা আর আরেকটা একটু ডিফারেন্ট থাকে, মানে যে এরকম দেখতে হয়। I'll explain why it happens like that. But can you tell me if one and the other is slightly tilted? মানে they're not perfectly opposite, slightly opposite. Would you have a perfectly destructive interference? No, right? What will you have? Yeah, basically my question was 180-degree phase difference, what's the resultant? 0, right? But what if it's not 180? What if it's 179? What would you see? Will it be perfectly cancelled out, or will you see something there? Yeah, you'll see a bit of it there, right? So to bit দেখা যাবে এখানে. Then if I go a little further to the left, right? আমরা দেখি যে এটা আরো একটু tilt হয়ে যাচ্ছে এভাবে. Do you think this is going to completely cancel out, or now will you see some wave? Yeah, we'll see some wave, right? Because it's not fully cancelled out. If I keep going further, right, এটা ধরে যে এখন এরকম হয়ে গেল. What do you think? Is it completely out of phase, or is it completely in phase, or it's just middle ground? Middle, right? কারণ পুরোটা যদি align হয়, let me explain. Okay, if they're fully aligned, what do you have? If they're fully aligned, এই যে pencil গুলো দেখাই, if they're fully aligned, you'll have constructive interference. If they're completely opposite, what will you have? Destructive interference. But what about everything in between? What are those? Just interference. They're not maxima, they're not what either. Minima. Minima hoy when they're perfectly opposite to each other, or maxima hoy when they're perfectly what? Aligned with each other. What I'm showing you right now is এরকম. So এটা যদি perfectly aligned হয়, আর এটা যদি perfectly unaligned হয়, isn't this somewhere in between? So wouldn't that mean that it's not completely in phase, neither it's completely out of phase, it's right in between, right? So এটা হচ্ছে ধরো এরকম একটা জায়গায় হচ্ছে, because এটা যদি completely out of phase হয়, this is going to be in between that. But let me not get away from my point. Next কি হচ্ছে আমি বলি, এটা আর একটু কি করা স্টার্ট করবে, উপরে যাওয়া স্টার্ট করবে. Do you notice that this thing is rotating? So it goes a little up, and then the one that I want you to focus on is এই জায়গায় এসে go a little up like that, and next কি হবে? Completely aligned. Do you see the cycle? A cycle টা বুঝা খুব important, okay? So cycle is the waves are completely out of phase to begin with, but over time, gradually, what do they start to become? In phase. And eventually, what do they become? Completely in phase, right? Can you tell me when they're completely out of phase, what would my amplitude be? 0. তারপর amplitude কি 0 হবে না, একটু বাড়বে, তারপরটা কি আর একটু বাড়বে? Yes. So as you keep going this way, doesn't it get more and more aligned? And by the time you reach the center, right, what would the amplitude be? Highest possible, right? And this highest possible amplitude that you see is referred as a what kind of interference? Constructive interference, right? So a sequence টা যে দেখতেছো এটা এখন will make sense to you. This is exactly how the rope moves. So when you look at the rope move, right, rope টা movement এরকম দেখতে হয়. So look at this. This is the rope, right? You plug the rope at the center. What was their anticipation to see waves, right? Waves দেখা যায় না, কি rather দেখা যায়, the rope as a whole does this, like that. Remember I showed you last class? And এটা যদি structure-টা একটু দেখো, doesn't that match the structure I've drawn? Halfway থেকে দেখবা, okay? Doesn't it look like that? Like, 0 at the end, and then it keeps increasing and the center is the highest, right? And that is what the stationary wave is. A stationary wave is basically the resultant of what? Many waves in the background doing what with each other? Interfering with each other. And as they keep interfering with each other, right, they result in a structure that looks very unique. It looks like this. এরকম দেখতে. And that is known as a stationary wave. And the reason why it's called a stationary wave is because if you look at it, it doesn't really go anywhere. Do you see? দেখে মনে হয় না just here, normal wave কিভাবে travel করে সামনে যায় না, right? But this just stays here and just goes like that, right? So that's why it's called a stationary wave. But that's not the real reason though. The real reason why it's called a stationary wave is because of the energy. Where is the energy? Where is it going? Nowhere. Isn't it stuck between the two ends, right? That's why it's called stationary wave, as opposed to the other wave, which is known as a what wave? Progressive wave, where what happens to the energy? It goes somewhere, right? So stationary wave definition comes from the fact that the energy is confined, restricted between two fixed points. It really can't go anywhere, okay? So yeah, that's the structure that you get. So once you take all of this into account, what do we see? আমাদের সিলেবাসের মধ্যে এটার অ্যান্সারটা হচ্ছে খুবই বেসিক, বাট আই ওয়ান্ট ইউ টু নো দ্য অরিজিন অফ ইট. অ্যান্সারটা একটা টেমপ্লেট, সব জায়গায় সেম লিখবা, 3 মার্কস দিয়ে দেয়। আচ্ছা, সো দি অ্যান্সার ইজ or the diagram for stationary wave looks like this. So এরকম দেখতে হয়, and always যে জায়গাগুলোতে fixed থাকে ওইসব জায়গাতে wave গুলো 180 phase shift করে. So these will always result in the formation of a what? Node. Node মানে what's the vibration? 0. And at the center, what do you have? The place where constructive interference takes place, right? Because they're perfectly aligned. And these are known as antinodes. And antinodes have double the amplitude of the original wave. Because remember, perfectly constructive interference. And question out here, why do you have an antinode at the center? Again, out of all places. Reason is actually simple. And when you pluck at the center, waves are generated, right? Which way do the waves go? Left, right, or both? Both ways. So এদিকে একটা ওয়েভ যাচ্ছে, এদিকে একটা ওয়েভ যাচ্ছে। ওরা ওইখানে গিয়ে রিফ্লেক্ট করে and they become opposite and they come back and they come back. And by the time they come back to the center, aren't they the same waves again? Just the other way around, right? So imagine this, okay? This is interconnect thing. Look at that. I hit the wire at the center, two waves are generated. These are waves, okay? They're going like this, right? They hit the boundary. And what do they become? Inverted. And then what do? They come back to the center again. Aren't they again completely in phase to each other? So what will you expect again at the center? Constructive interference. They'll go all the way there. And what will they do again? Flip and become straight, and they'll come back here. That is one cycle. And that's the reason why, notice karo ki hoy, if I plug this, it starts here. Then which way does it go? All of them down. That's the ones that are down. Then what happens to them again? They come back to the top again. So when you see the top version, is basically the waves are going like this. And then what do? Reflect and go the other way, right? So when they reflect and go the other way, the whole wave becomes like that, right? And that's why it's a cycle that goes like this, back and forth, okay? So that's the stationary wave. Now, how is the amplitude 0? Good question. Amplitude 0 hoy khali edge gulote, where the two waves have exactly same frequency, same amplitude, same wavelength, same speed. So when they meet with each other, right, what's the result? Destructive interference, right? And remember, there was a thing about waves interfering to produce constructive, destructive, that they need to be coherent, which means they need to be the same. Are the waves the same? The ones that are incident and the ones that are reflected? Yes, they're basically interfering with themselves. They can't be any more same than this, right? So therefore, they go like a perfect scenario like this, okay? So yeah, that's the thing. Now, exam, if they ask you how stationary waves are formed, right, what would your answer be? It's pretty straightforward. Listen what I say. When a wave is generated on a string, a convex string, waves travel along the string and they interfere with each other after reflection. So the incident and the reflection interfere with each other. At some places, the waves are completely out of phase and they result in the formation of what? A node. And in some places, they're perfectly in phase and they result in the formation of what? Antinode. That's it. That's all you say, okay? And etai hocche the basis of stationary waves, that the waves will keep interfering with each other and they form this perfect scenario called a stationary wave or a stand-in wave. That's also another name, okay? So yeah, that's how these are formed. The biggest challenge in teaching this is the fact that what you see, right, is not actually the wave. What is it? A structure যেটা এখানে, the one that you see here, যেভাবে করে up and down যায়, is that the wave? No, right? What is it? The result, okay? And that's what students fail to understand. They think this is the wave, but this is not the wave. What is the wave actually? Just typical transverse waves. But once you set it into stationary wave, it forms this pattern, and this is the net pattern, the resultant pattern, okay? Right, so that's your stationary wave introduction. I'll give a note on this, but Tarak, if you have any questions, I'm going to ball. I'll try to clarify. Stationary waves are formed in any wave, okay? Sound wave, light wave, microwaves, radio waves, whatever waves you can imagine, all right? They are formed when a wave goes and hits a boundary and it comes back, and the incident wave and the reflected wave interfere with each other, right? Which means the boundary will always result in a node. Why? Why is the boundary, when they reflect, right, always going to be a node? What's the reason? Yeah, but why is the destructive interference only there?
That point, the waves reflect 180 degrees or has a phase difference of 5 to the incident.
Right. So the node, right, the place where they reflect, is the moment when the waves turn what to each other? 180. So waves will and they hit the boundary and they're now going like that, right? So right at the boundary, the incident is coming in and the reflected that is upside down is coming out. So wouldn't they meet at that point and destroy each other, right? So that's why you'll find there's always a node at the fixed points, okay? Our machine ki hoy ekta antinode, because these waves will eventually come and meet with themselves in the right orientation. So what would that result in? Constructive interference, okay? What students sometimes fail to understand is that wave to dudike jay. Duitai ki kore je ki phase difference hoy. So when they come back again to the center, what are they in phase, right? So you'll always have a what at the center antinode, okay? This is a closed and stationary wave. So stationary wave there are types we'll see pipe se hoy, like open end thake ekta active closed thake, but this is a closed end version. You're right. Okay, so I'll give you the notes on this, and I'll show you a few more animations on this.
So what if you don't plug this string in the center?
Yeah, it doesn't form. It struggles to form, and then eventually it will try to form, but it struggles because they're not synced properly.
And what if the ends are not tied?
Then it doesn't form.
So specifically clear.
Fixed thakte hobe, right?
What if only one point was
It still works because that would then become your antinode and the other would be node. So it'll form like a half of a stationary wave. Yeah. Okay, so there are two answers here. Actually, textbook version ota ami dicchi, but age eta ekটু দেখে নেই. Textbook মানে marks scheme যেটা prefer করে. আচ্ছা একটু দেখে নাও, whatever I just described, it's written here, but let's see what's mentioned here. So you can see that there's a wave going here and hits this thing and then comes back, right? So going in and coming back. So there are a lot of waves that are moving in and there are a lot of waves that are moving out, and at different places they interfere in different ways, and that results in this formation, right? So in this scenario, the wave reaches the other end, the fixed end does not utilize the energy, so the energy ta nite pare na, so the energy is returned to the rope. Based on Newton's third law, the force exerted is in the opposite direction to the wave. So the wave jodi niche dike jete chahe, this fixed end will push it back up. As a result, the reflected wave is completely out of phase. So jeta ferot jacche is completely out of phase. And the completely out of phase and the original incident wave work with each other, interfere, and that's when you have this stationary wave formation here. And this is another version of it. But there are different ways of representation. There's no one perfect way. Unfortunately, I've seen the সবগুলো একটু complicated মনে হয়. So I've given like multiple versions of it. And the other thing that you need to know is the textbook answer যেটা আমি একটু আগে বলছিলাম, ওটা লিখে দিচ্ছি এখানে. So the resultant wave represents itself as one wave. Yeah. So the resultant is what you see as that one wave. Right. So how stationary waves are set up in a wire. When the wire is plugged, the waves are generated that travel along the wire. These waves reflect and interfere with the incident waves. The interference leads to destructive and constructive. Destructive গুলোকে nodes বলা হয়, or constructive গুলোকে anti-nodes বলা হয়. Okay, so that's the exam version. It's, I think, one of the most repeated questions out there. Whenever stationary waves আসে, the first question is this, that how is it set up? It's always the same thing. And তোমাদের syllabus mostly string আসে, so it's exactly the same thing. Okay, right, so I'll give you a couple of minutes on the copy করা থেকে করে নাও. এরপর I'll look into the properties of stationary waves. how the incident wave pulls the nodes downwards. So what actually happens is, I'll show it here. So this is the fixed end. And you have the rope that's tied there. And you have the wave coming in. There's the wave moving in. So yeah, so you have your wave here. It's moving towards the rope there. Now what happens is, as this part, which is energy, as this energy comes here, right? The ring was supposed to move downwards because this thing will pull the ring downwards. But what happens is the ring can't move downwards. So this thing can't really go down. So as a third law pair, the force that's exerted by the ring on the wave is upwards. Because if you look at the original force, this is force of wave on ring downwards. The third law pair would be force of ring on wave upwards. So what happens is that the downwards part that you see here, this downward part, right? This experiences a force upwards. So it starts to move up and it changes its phase. But if the ring was not tight, the ring can niche move course and this wouldn't have happened. So imagine you push a wall, and if the wall is fixed, right, you can't push the wall, so the wall pushes you back. But let's say you push a wall and the wall can move, telling into it, the wall will just move. So when it's open, like the ring is loose, the ring moves, and there's no third law interaction per se. But if the ring is tight, it generates a force back onto you. And that's what becomes opposite. And that opposite wave interferes with another wave that's coming in. And they create destructive interference. And that's where you have a node there. Antinode is when the two waves come back to the center. And they're exactly identical waves. Also, they're completely in phase. So what do they do to each other? Constructive interference. Sorry? Antinode, two reflected waves. So originally when you pluck it, you produce two waves, right? They go the other way, they get reflected, and they come back to the center again. Aren't they the same waves that came back to the center? Because both of them got reflected the same way. That's when an antinode forms. Last class, I showed some animations, right? Towards the end. Did I show you any real life scenarios? Yeah, with a student and a teacher, which I think I'll show you more later. Oh yeah, I'm clicking on the report. Look at it later on. You guys done? Okay, so wait, this thing let's move on. So this is the fundamentals of state. What does that mean? It can be set up in sound, it can be set up in string, parameter wave, logic wave, anything that you want rotor waves. সব জায়গায় possible. Okay. So এখন যেটা আমরা করবো is page 49, okay? So this is formation of formation of stationary waves on a string. So we need to see how the waves are actually formed. So I give an example using string, I know, but এখন string এর আরো অনেক feature আছে ওগুলো আমরা দেখবো, okay? তার আগে just want to see on syllabus there was a change here. What was the change? Right. So তোমাদের হচ্ছে তিনটা জিনিস হচ্ছে ফুল ডিটেইলস এ জানতে হবে। It's in the syllabus. আমি তার জন্য একটু ক্লারিফাই করে নিই because you might be wondering is there more to this or not. Point 2 টা দেখো। So এখানে first point যেটা explain explain and use principle of superposition. That's the waves interfering. We've done that the other day, right? Explain the formation of stationary wave using a graphical method and identify nodes and antinodes. This graphical method is the idea of using two waves one on each other to find the answer. Okay, so they want like a representation in terms of the wave itself. It only can mistaken for like you need to draw a graph or something. There's no graph to draw here. Do you remember I showed you a question the other day with a blue wave and a red wave where they met and we had to find the result then? And imagine I give you like two waves that are curves and I ask you to do the same thing. Wouldn't it be very similar to that? What do you need to do? Find the values at different points and then join them together. That's the graphical method. Okay, এটা হচ্ছে just nodes and antinodes লাগে, so you don't need to bother about that much. আমি যেটা বলতে চাচ্ছি is this one. Look at this. Point 2. Show an understanding of experiments that demonstrate stationary wave using microwave, stretch strings and air columns. So তিনটা জিনিস ওইটা আমরা আজকে স্টার্ট করব। So আজকে string করব। Hopefully next class I can do microwaves and the column as well. Okay, so that's the demonstration that we need to know. And that's the end of the topic actually, okay? But এই string টা নিয়ে অনেক কিছু করতে হবে, so let's see. Right, so screen এ কিছু লেখা লাগবে না, just বোঝার চেষ্টা করো। How do you investigate a string মানে in terms of stationary waves? আমরা যেটা করব, we will take frequency generator here and frequency generator হচ্ছে a device that can make something oscillate. So তোমাদের syllabus whenever you draw the diagram you need to be very specific about the parts. Of course ASA you don't have practical design, but A2 তে গিয়ে এই same question টা আসে, so আগে থেকে বলে রাখলাম। So what are the parts to this setup? So you have something called an oscillator. Oscillator টা হচ্ছে উপর নিচে move করে and it generates the wave. It's very similar to your dipper in your ripple tank, remember? This one is called the frequency generator. This is a device that you can use to set whatever frequency you want the oscillator to move at. Frequency generator. And Cambridge is very adamant about this part of the diagram. Do you know what that is? I feel it's redundant. Power supply. Okay, I mean it's kind of obvious that doing power supply they connect করবো জিনিসটা, but power supply না দিলে মার খাবে. Okay, so you have your power supply connected to your frequency generator which is connected to your oscillator. Oscillator টা করে কি? Oscillator টা এখানে যদি কোনো কিছু থাকে ওটাকে হচ্ছে একটা পিন দিয়ে ঘোরাতে থাকে and this rope will then be moving like that and what will be generated on the rope? Wave. I've shown that in my animation. Remember there was a thing that moved up and down and produced a wave. ওই জিনিসটা, okay? এখন আমরা যেটা করব এই end এনে at this end, right? We will hang a string. So there'll be a string hanging from here. Reason to bold this, we need to apply what on the rope? Tension. Okay, so you can weight thakbe and that's gonna apply what on the rope? Tension. Okay. Now here's the interesting thing. I have a rope here at the center. Ami jeta korbo is I will provide an oscillation, right? Rope te ki kore dekho. If I provide 1 hertz frequency, I'll notice the rope just do something like this. Do you see the rope move once in a while like that, right? Stationary wave form hoy na, surprisingly. 2 তে দিলে কিছু হচ্ছে না এরকম। 3 তে দিলে মানে কিছু stationary wave যাই anticipate করতাম তা হয় না, we just see some vibrations out there. 4 এ কিছু হয় না, 5 এ কিছু হয় না, 6 এ একটু মনে হয় যে stationary wave হওয়ার চেষ্টা হচ্ছে, 7 এ মনে হচ্ছে একটু বেটার হচ্ছে, 8 আর একটু বেটার মনে হচ্ছে, 9 almost হয়ে যাচ্ছে, and then once you reach 10 you have a perfect stationary wave. So what we learn from here is that stationary waves don't just form, they have to have a certain condition for them to form. So for whatever you see, stationary waves will form at a very particular frequency, randomly form হবে না. And if you play musical instruments, right, guitar for example, you will notice this happen. So guitar মধ্যে if you have a string, right, and you plug the string, just একটা plug করলা, stringটা কি করে, vibrate করে, কিরকম vibration হয়? Do you see waves or do you see stationary wave? Stationary wave, right? এখন what we find is that stringটাকে তুমি যেভাবে vibrate করো, like whatever you do to the string, what sound will be generated? Same sound, right? এটার example টা এখানেও দেখাই. So if you look at this scale here, I set it at 25 centimeters, right? And I hit the scale to produce a sound. Do you hear a sound? Which I'll increase the sound. So let's say 30 the day. You hear the sound, right? However I vibrate this, right? Sound in the same থাকবে. So if I do this, if I do that, it's the same sound. এটা করলে soundটা কি হয়? Louder, okay? But what doesn't change for the sound? Frequency. So if I do that, same sound হচ্ছে কিন্তু. It's just you can't hear it very easily, right? But if I do this, it's just louder, right? So the point I'm trying to say is that whenever there's a wave set up in a string, right, it will always form at that frequency. Our wave frequency ছাড়া কিছু হবে না. So in this string that you see here, এই stringটা তো আমরা জোর করে vibrate করালাম using what frequency? Our frequency. এই stringটাকে তুমি যদি randomly গিয়ে বাড়ি দাও, right, what frequency will it like vibrate at? Like you just go and take the string and you just pluck it, right? Vibrate করবে না? At what frequency will it vibrate? The frequency that's needed to form a stationary wave. And what was that value I found? 10, right? So this frequency is known as the fundamental frequency. What is the fundamental frequency? It is the frequency at which the stationary wave forms here. Fundamental frequency. এটা হচ্ছে the frequency at which you see your first stationary wave. Clear? আচ্ছা, এখন I will do this experiment with you guys and show you something interesting that happens here. So, sorry?
What if you go above
If I go above it, we did that. Okay, সবাই একটু স্ক্রিনে দেখো, let me show you the experiment. This is how you do it. So it's the same thing. মানে আমি যেটা বুঝালাম, same setup কিন্তু ওরা এখানে কি ইউজ করছে, rather to produce frequency, a tune-in fork. Do you know what a tune-in fork is? Tune-in fork. Did I show you tune-in fork? No. I think I showed it, right? The tune-in fork. It's basically this. এটা হচ্ছে তোমাদের সিলেবাসে ওরকম ইউজ হয় না, বাট প্র্যাকটিক্যালে দিতে পারে, যেন দেখে রাখি ইজ দিস থিং, ওকে? সো এটা যেমন it says here 384 hertz, right? So if I do this, that's 384 hertz I'm hearing right now. আচ্ছা, constant frequency produce করতে পারে. So just have to give it energy and it produces the sound like that. Whatever you do, যেখানে বাড়ি দাও, any place I hit, right, what would the frequency be? 384. Now if I hit it very hard, right, what would the frequency be? 384. If I softly hit it, what is it still? 384. The difference key, loudness. So if I hit it really hard, I can hear the sound from here, for instance, right? If I just tap it like that, now I hear the sound. So that's the difference. So tune-in fork is basically a device that can produce a fixed frequency. We use it in practicals a lot because on the practical, say frequency generator provide করে না, right? So tune-in fork provide করবে. However, disclaimer, I've never seen this in your Cambridge practical. Cambridge, I've never seen the tune-in fork being used, okay? But if you ever have to use a generator frequency, this is what we use in labs, okay? So you have your frequency generator here, 45 hertz এ দিচ্ছে, and I turn on my এই জায়গাটার মধ্যে I have the rope here. Do you see the rope vibrating? No, right? কিছু ওরকম হচ্ছে না। আমি কি করে ফ্রিকোয়েন্সিটা একটু বাড়াবো slightly. Do you see the rope vibrating now? Yes, but stationary wave কিন্তু ফর্ম হয় না। আমি বলি stationary যখন ফর্ম হয়, it's very obvious. এগুলা stationary wave না কিন্তু। What's a stationary wave? That, like, it'll just go out of control. Just হালকা এগুলা না হলে কিন্তু it's not considered stationary wave. So now you can see something that looks like a stationary wave, but it's not. Okay, let's see কেন। So if I go a little further, 50.78 থেকে 59 এ যদি যাই, sorry, এই do you see that? That is what forming on your string, a stationary wave. But the question is, why does it look like this? আমরা তো এটা দেখি নাই. What did we see? That one pattern, যে এরকম দেখতে, এরকম দেখতে. What is going on here? So that's what we're going to learn right now. But one thing I want you to see before I move on, do you see this point? Is that moving or fixed? Fixed. No, ওই হালকা movement না. Like, is it moving all the way up and down? No, right? Do you see this point? Is it moving all the way up and down? No, right? একটা interesting জিনিস দেখাই, এই যে A pointer. Do you see where my mouse is? এটা কি move করতেছে? No, right? Isn't the line on my mouse all the time, right? So what is that point as well? Fixed. If I go here, there, isn't that fixed as well, right? Now you might be thinking the সব জায়গায় fixed না, এই যে কোথায় লাইনটা সরে যাচ্ছে, right? So there is a point here where if I keep my mouse, right, you'll notice it doesn't really move, is it? That point. Do you see that? So that's the what point as well? Node. Okay. So the question now is, why are there so many other nodes here? Are they egla ki? Antinodes, right? So that's what I'm going to show you right now. Oita hocche is due to something called harmonics. How are harmonics generated? So do you see the frequency here is 10 hertz, right? So 10 hertz, when I have my stationary wave, it will be the most basic form possible. এই যে উপরে যাবে আর নিচে আসবে, and it is the smallest stationary wave possible. It's ছোট possible না. However, listen very carefully, okay? What if I double my frequency? So when your frequency বাড়ায় double করি, right? Would the size of the wave be same or would it become smaller? Frequency and wavelength relationship. Higher frequency means what wavelength? Smaller wavelength. So if I increase my frequency, wouldn't the wave narrow down? But when it narrows down to half, can't you have another one as well in that same space? So what happens is, as you double your frequency, you'll end up having two of these things. এগুলাকে আমরা segment বলবো. এই two segments form হয়. And এই two segments কেমনে move করে? যেটা up and down move করে যখন, এটাও কি করে? Up and down move করে, but they move in what manner to each other all the time? Opposite. একটা উপরে গেলে আরেকটা নিচে. Just what you saw. I think the one we saw wasn't two. How many segments were there? Three, right? কেমনে possible? Triple frequency. So if I triple my frequency, wouldn't my wavelength become 1/3? So how many segments can I fit into the original length? 3. And if I do that, you'll end up with this structure. And that's what you guys saw. And can you tell me how many nodes are here? একটা node এখানে. Yeah, there's one here. There's one here. And then there's one there. Do you notice that? And wasn't that the thing that we saw, right? So the idea is stationary waves will form at a base frequency called the fundamental frequency. Erpore, when do they all return? When do they all return? মানে stationary wave cover back কখন করে? Yeah, whole number multiples of the base frequency. What's whole number multiples of the base frequency? 1, 2, 3, 4, 5. So 10 এ যদি হয়, next কখন হবে? 20, তারপরে কখন হবে? 30, 40, 50. You get my point? Let's prove that. Maybe I'm wrong. Achha, so experiment if it's possible or not. So একটা জিনিস notice করো, take your calculator out. Anyone can do the math. A stationary wave frequency data note করো. What is the frequency here? The frequency at which this is oscillating. 52.43, right? How many segments are here? So can you tell me what is my base frequency? Base frequency বুঝছো কোনটা? The first time it happened. এটা কি third time হচ্ছে না? So third time কি 3 times the base frequency হওয়ার কথা. So what's my base frequency? Yeah, so 52.43 divided by 3 কত আসে? Yeah, 17.48 was when this happened. বুঝছো? সিঙ্গেল, তারপর নেক্সট কখন হবে ইনটু 2 করো, রাইট 34.9 whatever you said, তখন কি হবে? তখন কিন্তু হচ্ছে দুইটা সেগমেন্ট হবে, যে এদিকে একবার উপরে এদিকে নিচে, উপর নিচে, মানে this goes up this goes down. I can't really show it here, but এই যে এদিকে উপরে যাবে এটা, এদিকে এটা কোন দিকে যাবে? নিচে যাবে, right? That's two segments. When will the third one show up? This one, whatever value you had, কত ছিল বেস বলতে একটু লাগবে, 17.9, yeah, into 3 করো, তাহলে তো এটাই আসবে মনে হয়। আচ্ছা, can you tell me when will I see the next station wave? এই যে এটার পরে নেক্সট কত ফ্রিকোয়েন্সিতে শো আপ করবে? How did you do that? কেমনে বের করছো? Base into, yes, very good. আচ্ছা, let's see if that's true or not. কত? 69.9. okay, so let's change the frequency. দেখো কি হয়, everyone carefully. So 52 থেকে আমি একটু বাড়াবো, এই যে 59 এ গেলাম, what just happened? The whole thing disappeared, right? Now what's the reason it disappeared? এই অ্যানিমেশনটা অ্যাকচুয়ালি পুরোপুরি বোঝানো যাচ্ছে না, I don't think you can see it, but there are waves here, but waves গুলো কি ফর্ম করতেছে না, stationary waves. So what are they doing? Just randomly moving around like that. So যদি এই ওয়ারটা real life এ দেখো, you'll notice it's just doing like that. In fact, a human eye can't pick it up, because our human eye can't see frequencies of 60 hertz. It's too fast for us. 10-15 হলে তোমরা এরকম কিছু একটা দেখতে থাকবা, when it's 60 hertz it's like stationary for us. Slow motion camera there you can notice them vibrate, right? So yeah, 60 তে কিছু হচ্ছে না. Let's go a little further. 65 এও কিছু এরকম নোটিসেবল দেখা যাচ্ছে না। 65 থেকে right 68.9. See who's back again. Do you see the stationary wave? But you guys told me what value, right? So আমি যদি আর একটু বাড়াই, I think this would get better. No, এটা কমে গেছে. Can you tell me why did it go down again? Yeah, because I crossed that sweet spot, which was what, 69 point something. So এটা যদি আনতে পারি, এখানে আনা যায় না unfortunately, তাও চেষ্টা করি। Yeah, I think this should be it. Yeah, there you go. The greatest amplitude out there. And this is when what happened? Perfect stationary wave form course. So yeah, stationary waves only form at fundamental frequency and they're what? Multiples, okay? And here's a very big disclaimer. Strings are journal. The multiples are what numbers? Whole numbers. But flute, for example, when a flute মানে কি এক সাইডে close, এক সাইডে open, তখন কিন্তু multiples গুলো different হয়। Odd numbers হয়, even numbers হয়, random ratios হয়, random sequences হয়. But the idea is that they'll always follow a what? Pattern. They just don't randomly form, okay? Right, so next class you have your test exam. Tomorrow school is the next class. Sorry, next week. Do you have your school? Like every day. When does it close? 22nd. And when does your school close? Oh, your winter vacation is over. Organic technician. No. You have to like this is the moment so hard.
After us become constant.
Yeah, because when your object is can draw here.
Yes.
When your object is partly in, right? Upthrust is because of that much. Then when your object is a little bit more in, upthrust is because of that much. But when your object is fully in, upthrust is because of the whole thing. And then as you continue to go down, this is the full thing in the water. So you have the greatest upthrust. So upthrust keeps increasing as your object partially starts to enter the water. When it's completely inside the water, the upthrust becomes constant.
explain why it becomes constant?
So what is the formula of upthrust? Volume of object, density of fluid into G. When you have the object completely outside water, right? What is the volume of object inside water?
Same.
No. When the object is completely outside water, what is the
Zero.
volume? Zero. So it starts from zero. Then you put the object in little bit. Isn't that volume like a small amount? So now upthrust is like a small amount. You put it further into the water, the upthrust is a little higher. You put it further into the water, the upthrust is higher. And then now you're completely inside the water. Isn't that the entire upthrust?
Yes.
And that can't change anymore because upthrust depends on volume, density, and G, right?
Volume isn't changing.
Yeah, so that's will be constant. So wherever you are in the water, the upthrust will remain what? Same.
That actually so this
Which one?
this this ball was submerged inside, and it shows that why
So you explain what happens to the acceleration of the sphere as the velocity begins to increase. The axis upwards but remains entirely below.
after it is submerged, fully submerged.
Oh, so this will be like terminal velocity. So the object is fully underwater, right? And as the object is moving up, what is the upward force here? Upthrust. What is the downward force here?
Yeah, to discuss the drag force, sorry,
Drag force and
drag and weight.
weight, right? So as you go faster and faster, as the velocity increases, right? Isn't the drag force getting higher and higher?
Yeah,
At one point, the upthrust and the weight plus drag would become what? Equal, and it might reach terminal velocity. This one.
6 centimeter.
Unstretched spring is 2 centimeters. The spring is stretched within a limit of proportion to 1.4. So the elastic potential is young modulus of the problem. Why can't I use young modulus?
Because there is no force already.
Yeah, it's a spring. Spring to a shape. You can't apply young modulus for shapes. You can apply young modulus for material. So you have to use the formula half kx squared or half fx for the energy. So the spring is stretched within a limit of proportionality by tensile force of 1.5. So that the elastic potential energy is 0.045. Yeah, so you use this one to find the extension, and you know the original length plus extension will give you the stretch length. Did you get my point?
Yes.
Let me try it. 0.045 into 2 divided by 1.5. That's 0.06 meters into 100. That's 6 centimeters plus 2 is 8.
Forgot the